All right, welcome to The Explainer. Today, we are diving deep into this super high-stakes world of AI that can literally read your brain over time. We're talking about a global race, cutting-edge science, and something that's totally changing how we think about brain diseases.
So let's kick things off with a really big problem in neurology. How do you track a disease that moves in super slow motion? I mean, think about it. It's like trying to watch a flower bloom by only glancing at it for a second, once a month. You'd miss everything, right? Well, that's exactly the problem with diseases like MS or Alzheimer's. The changes are so subtle, so slow, that if you just look at one single brain scan, you're pretty much flying blind.
So what's the answer? Well, it's basically creating time-lapse photography for your brain. Seriously, this technology lets doctors stop looking at just a single snapshot in time. Instead, they can watch the whole story of the brain unfold frame by frame. And that gives them this crystal clear view of how a disease is progressing, or, just as important, if a treatment is actually working.
Okay, so what is this powerful new tool? Let's dive in and take a look under the hood.
Okay, the official name is Longitudinal MRI analysis. And what that really means is using AI to automatically track changes between a series of MRI scans from the exact same person. We're talking about measuring things with incredible precision, stuff like brain shrinkage, that's called atrophy, or how lesions are growing or changing over time. You know, this is a huge shift in how medicine works. For decades, radiology has been qualitative. A doctor looks at a scan and says, this looks a bit worse. It's an expert judgment call. But this new tech, it flips the script. It moves us to a quantitative trajectory. We're talking hard numbers, cold, hard data that maps out the exact path of a patient's brain health. It's not a guess anymore, it's a measurement.
And as you can probably guess, this kind of game-changing potential has kicked off a massive global race. I mean, companies from all over are scrambling to build the best AI and get it into every single hospital and clinic out there.
And what's really cool is seeing how these different companies are playing the game. They're all taking a different angle. You've got icometrix out of Belgium, they're a big leader in MS, and they also have the first FDA-cleared tool for spotting side effects from those new Alzheimer's drugs, super important. Then you have quantitative from the Netherlands, and their whole bet is on data privacy. They keep all the processing local. And then there's QNAPs, a French-American company, and they've built their cloud platform to handle these huge, complex clinical trials that span multiple hospitals.
And the results? They're pretty staggering. Take icometrix, for example. They report that their AI boosts the detection of disease activity in MS by a whopping 150% compared to just a standard human read. I mean, think about that. That's not just a little better. That's a gigantic leap.
And this really highlights one of the biggest strategic fights happening in this space. Where do you actually process all this sensitive brain data? Do you go with the cloud, which is super scalable and easy to access from anywhere? That's the route QNAPs and icometrix are taking. Or do you prioritize absolute maximum data privacy and keep everything on-premise, safely behind the hospital's firewall? That's the strategy for companies like Quant. But, you know, this whole commercial race is really just one side of the coin. The other half of the story? It's all being built on this incredible foundation of work coming out of academia and the open source community.
Yeah, a really good way to think about it is that these university labs aren't the ones in the race car. Nope, they're the genius engineers building the engines and designing the actual racetrack that all the commercial companies are competing on.
So let's look at FreeSurfer, this incredibly powerful tool that came out of Harvard and MGH. Its process is just so smart. First, it takes all of a single patient's scans and builds a personalized, unbiased template, like a perfect average of their own brain. Then, it uses that custom template to measure each individual scan. What this does is it cuts down on all the noise and bias, letting it spot tiny changes that would otherwise be missed. It's no wonder this thing has become the gold standard for researchers.
And the innovation just doesn't stop. Take a look at this AI called MindGlide from University College London. Now get this, it was trained on data from nearly 600 different MRI machines. Why is that such a big deal? Well, every MRI scanner is a little different, which makes comparing scans a nightmare. This tool is designed to solve that exact problem, to be scanner agnostic, meaning it doesn't care what machine the scan came from. It can still give you a reliable answer.
Okay, so we've got this amazing race happening between the big companies and the brilliant academic labs. But let's bring it back down to earth. What does all this actually mean for patients? You know, how does this code actually make a difference in the clinic?
For anyone with multiple sclerosis, this is a flat-out game changer.
These AI tools can automatically do the really tedious but absolutely critical job of tracking lesions to see if they're new or getting bigger. That's a huge sign of disease activity. Plus, they precisely measure that brain atrophy we talked about, which tells doctors about the long-term picture. All this means faster, more objective decisions about what treatment is right.
And the real-world data, it's just undeniable. Check this out. One study found an AI system was able to detect new MS lesions with 93.3% sensitivity. Now compare that to the standard reports from human radiologists looking at the exact same scans, just 58.3%. The AI is just seeing things that the human eye is missing. Period.
And it's pretty much the same story for Alzheimer's. These tools give doctors objective numbers on brain shrinkage in critical areas, like the hippocampus, which can help support an earlier diagnosis. But here's where they've become absolutely vital. With these new, powerful Alzheimer's drugs, there can be dangerous side effects like brain swelling or bleeding, the condition's called ARIA. Well, this AI is now essential for automatically spotting those risks and keeping patients safe.
And it doesn't stop there. The list of applications is just exploding. We're seeing the same fundamental technology being used for traumatic brain injury, for tracking tumor growth, and even for monitoring changes after a stroke or in Parkinson's disease. It's spreading everywhere.
So, where does this race go from here? What are the last big hurdles to clear before this tech is just standard practice everywhere?
Well, the whole future of this field really boils down to solving 4 key problems. First, integration. How do you make these tools fit so seamlessly into a doctor's workflow that they don't even have to think about it? Second, harmonization. This is the big one, the holy grail, making data from any MRI machine anywhere totally comparable. And then you have the really practical stuff, regulation and reimbursement. You've got to get these tools approved as medical devices, and then you have to convince insurance and healthcare systems to actually pay for them.
When you step back, what this is all about is tracking these subtle, data-driven trajectories of our brain health. It's moving us toward a totally new frontier in medicine, one that's way more personalized and proactive than anything we've had before. And that leaves us with a pretty wild final thought. If we can watch the brain story unfold with this much detail, will we soon be able to predict the end of the story before the first chapter is even written?